In the process of doing a measurement, there is something very important to recall, and it's the fact of every measurement is going to have an error and is going to change the actual result. Sometimes this change is not important, so we can use the measurement. But how to express the measurements appropriately, taking into account this fact, okay? So this is why we use significant figures. Significant figures is the way the scientists use the process of measurement in numbers. So let me give you an example of how to apply significant figures. Let's say that we're going to measure something with a ruler. Okay, and let's say that this is 1 centimeter, 0 centimeters. Okay, that will be 0.5. And let's say that we have here an object. The object measures here. Okay, we can see that this object, the red object, it's going to have a measurement between 0.5 and 0.6 centimeters. But here is the situation. We cannot know exactly what is this measurement because the ruler cannot give us more information. So we have to decide a number between 0.5, a number 0.5 or 0.6 according to the measurement. In this case, it's 0.5. So we're gonna say that the object measures 0.5 centimeters. Okay, even that we know that it's not 0.5 centimeters. We can see it on the ruler, but we cannot tell more information. So we have to use 0.5. And this is where the significant figures are taking a good part in the measurement. So we're going to see here the rules we have to understand and to know how many significant figures does a number have. Okay? So the first rule is that, so let me write here rules. So the first rule is any digit different than 0 significant. Okay? So for example, 3,415 centimeters. So according to this, these digits are different than 0, therefore they are significant, so this number just has 4 significant figures. That's the first rule. Easy peasy. Second rule, so now we're going to get zeros involved, and the second rule is if we have zeros to the right, they are not significant. Not significant. So for example, let's say that we have 1,500 kilograms or grams. So 1,500 grams means that digit different than 0, they are significant, but these two are zeros to the right, they are not significant. So we have 2 significant figures. However, there's a rule that lets you put zeros to the right to be significant. The first rule is to put a decimal point. So you can use 1,500 and put a point here, and with this decimal point you're telling that zeros are significant. We have 4 significant figures. And the other option is that zeros to the right of decimal place of a decimal place at the end. Okay, of a decimal place, they are significant. Okay, that's the next rule. Any zero to the right of a decimal place is significant. So for example, 1.500 kilograms. Notice that both measurements are the same. 1500 grams and 1.500 kilograms are the same number. Just we just do conversion of units. But in this case we have two significant figures, and in this case we have the digits significant and the zeros to the right of the decimal place are significant. So these are four significant figures. So same values, but in physics both are different. One represents a measurement of two significant figures and the other a measurement of four significant figures. And maybe you will ask, but what is the difference? The difference is that the next number that I can measure here will be 1600 grams, and the next number I can measure here is 1.501 kilograms. Okay, more precise this value than this. Okay, more accurate. That's pretty cool. That's why we use significant figures. Now, next rule. The next rule is that any zero to the left of digits, it's not significant. What does it mean? For example, 0.00300 meters. So, digit, significant. 0 to the right of a decimal place, significant. Maybe you say these two are significant because they are to the right, but this rule says any 0 to the left of digits. So these three, not significant. We have three significant figures. This is the next rule. And the last rule is that zeros between digits are significant. So let's an example. 3050 newtons. 3050 newtons. So digit, 0 to the right, no, and 0 in between, significant. We have three significant figures. Okay? Sometimes in physics it is very useful to use scientific notation, because scientific notation helps you to give the appropriate number of significant figures. So for example, in this case, this value just have three significant figures, but maybe I can put it in scientific notation in this form: 3.05 times 10 to the third power newtons. So we still have three significant figures. Or maybe we can write it as 3.050 times 10 to the third power newtons, and nothing here, that we have digit, 0 in between, and 0 to the right of a decimal point, so it means four significant figures. This is a more accurate measurement than this. Okay, more accurate. This is more accurate than this. And this is why it is important to use significant figures in physics and in science, because it talks about the measurement. So remember, there are 4 rules for significant figures. The first, okay, 5 rules. The first, digits different than 0 are significant. Second, zeros to the right, not significant. Third, zeros to the right of a decimal point. I wrote place and I say place many times, or is point are significant. The fourth, any zero to the left of digits, not significant. And the fifth, zero between digits are significant. These are the 5 rules of significant figures, and I hope you like the video, that you make me comments about it, show me numbers and tell me these are the numbers of significant figures. And in the next video about this part, we're going to talk about the rules when you operate numbers using scientific notation, so don't miss it. Like to the video, share it, subscribe to my YouTube. I hope that you enjoy the information that you're receiving here, and you can tell me anything you wanted to make me improve. Remember that all my social networks are UgoFim. So, see you in the next video, and I hope we can talk more about physics and science and significant figures. Goodbye.